This is Technip UK's pipeline fabrication facility, Evanton Spoolbase in the Cromarty Firth in northern Scotland. Technip, take it further. It's here at Evanton Spoolbase that individual 12-metre lengths of pipe are fabricated into long sections, known as pipe stalks, and subsequently installed offshore as subsea pipelines for the oil and gas industries. This custom-built spool base has been in operation since 1985 and has an extensive and highly regarded track record in the fabrication and assembly of rigid pipelines in all configurations, such as single pipelines, pipe-in-pipe pipelines, electric trace-heated pipe-in-pipe pipelines, and internally corrosion-lined pipelines, either corrosion-coated or insulated and corrosion-coated, and in the fabrication and delivery of associated tie-in spools and ancillary fabrications. Our values are operational. They have ensured our success in the present and will take us forward by sharing and living them each day. Ensuring the health and safety of our employees or those engaged in our activities, protection of the environment, and providing leadership to create a culture of high health, safety, environmental and HSE. Quality standards and continuous improvement is an absolute commitment at every level in Technip. Let's follow the fabrication and assembly process for 12-metre sections of pipe as they proceed on their way to becoming part of a long pipe-in-pipe pipeline. After numbering and a pre-weld inspection, they're rolled onto the alignment welding station, where the ends are preheated. This station is at the start of a welding line and cycle that welds the sections into nearly 1 kilometre long pipe stalks. At predetermined cycle times, a new section of pipe is added to the stalk, with each joint receiving the required amount of weld passes at up to 8 separate stations. Welding is crucial to the whole process, and at Evanton we have a full range of mechanized and manual techniques. Because the whole pipeline fabrication process is being done onshore, it can be done in a controlled way, to the highest technical standards. And if there are any problems, they can be dealt with quickly and effectively. From the welding stations, the pipe moves through visual weld inspection into the non-destructive examination area, where a full range of techniques are available. The primary examination techniques are traditional radiography, digital radiography, or automated ultrasonic examination, backed up by manual ultrasonic, magnetic particle, and/or dye-penetrant examination, as required. The next stage in the process is coating of the weld areas. This is carried out in the field joint coating area, where a full range of systems are available. Generally, mechanized 3-layer polypropylene tape wrap, or injection-molded polyurethane or polypropylene as required. One-kilometre-long pipe stalks are fabricated for both the outer carrier pipe and the inner flow line in a pipe-in-pipe application. The completed pipe stalks are then stored on the stalk racks or on the causeway, waiting for pipe-in-pipe assembly. Technip have designed and manufactured portable hydraulically operated push frames to push the inner flowline pipe stalks into the outer carrier pipe stalks. The carrier pipe stalk, fitted with a bell-mouth guide, is secured in a fixed clamp at one end of the frame, and the inner flowline pipe stalk is held in a sliding trolley clamp at the other end. There's a 4-meter workspace between the two sets of clamps to allow the spacers and insulation to be fitted to the inner flowline, and then a hydraulic mechanism capable of 100 tons of push simply pushes one pipe stalk inside the other, 4 meters at a time. About 250 pushes to produce 1 kilometer-long pipe-in-pipe stalks. The completed pipe-in-pipe pipe stalks are then stored on the stalk racks or the causeway, ready for spooling onto the particular reel lay vessel being utilized. Generally, this will be the Apache II or the Deep Energy, although other reel lay vessels in the Technip fleet or third-party reel lay vessels may be utilized. The first pipe-in-pipe stalk is pulled through a tie-in station situated within the hydraulic push frame, along the spooling rollers and through a set of approach rollers up onto the vessel's reel. A pawn system of connecting is generally utilized to connect the larger carrier pipe lead string to the vessel's reel. The next pipe stalk is now ready to be connected to the first, which is waiting in line. This is done in the hydraulic push frame and involves first welding the two inner flowline ends together. Non-destructive examination of this weld is cleared and the stick-out areas covered with insulation. A fire-retardant blanket is then fitted over the insulation before the landward carrier pipe stalk is pulled over the inner flowline weld area. After completing the carrier tie-in weld, the trailing end of the inner flowline stalk is cut to the desired 500mm stick-out, rebeveled and cleared by NDE, ready for the next tie-in. And then the whole process is repeated until the required pipe-in-pipe pipeline is on board the relay vessel in one continuous length, ready for deployment in the field. Technip is quite literally breaking new ground in more ways than one. A development that stands out as having major implications for the entire oil and gas industry is the first-time use of relay electric trace-heated pipe-in-pipe, developed to offset the risk of wax or hydrate formation in pipelines. This alternative to chemical treatment uses electrical current to heat up flow lines. Electric trace-heated pipe-in-pipe relies on the use of electrical cabling coiled around the inner pipe-in-pipe flow line. In this particular application, 4 heating cables and 2 fiber optic temperature monitoring cables are spirally applied along the length of the inner flow line. Technip has been working on this electrically trace-heated pipe-in-pipe concept for some time. There are several ways of dealing with internal pipeline corrosion, but the most effective way is to internally line prefabricated steel pipe stalks with HDPE, a technique utilized widely by Technip for controlling internal corrosion in water injection and water disposal pipelines. Technip developed a completely new cable application machine, CAM, capable of spirally applying the electric and fiber optic cables in a helix around the inner flow line. Each electric cable able to provide the required amount of energy individually, and each fiber optic cable able to monitor the flow line temperature individually. After winding the cables and fiber optic lines in place, the selected insulation can be applied, offering superior passive performance within a compact pipe-in-pipe design. Once the electrically trace-heated pipe-in-pipe pipe stalks are assembled, complete with electric and fiber optic cables, the cables have to be spliced as part of the tie-in of the electric trace-heated pipe-in-pipe pipe stalks during spooling. Electric trace-heated pipe-in-pipe is the new generation of pipe-in-pipe technology. Technip operates with some of the most advanced pipe-lay vessels in the offshore industry. The Apache II, for instance, plays a major role in delivering subsea infrastructure around the globe. And once offshore, advanced technology aboard the vessel delivers all the additional advantages of the reel lay method. During the pipe lay process itself, which utilizes a pipe straightener, tensioner, and monitoring system, the pipe passes through a welding station situated on the ramp. Here, anodes, valves, flanges, T-pieces and spoilers can be attached to the pipe as and when required. On multiple trip applications, subsequent tie-in welding, NDE and FJC is carried out on the next trip as required. With sophisticated dynamic positioning systems and a range of offshore construction equipment, the reel lay vessels can lay pipe with an unrivaled degree of accuracy in deep and shallow water, close to other offshore installations. Technip have reel-laid pipe around the world in every configuration and has set new records for deep water pipe lay. For all configurations in pipe laying operations, the reel lay method is unsurpassed technically and in terms of cost effectiveness. At Evanton, Technip has one of the most advanced spool bases in the world. Our reel lay vessels are some of the most advanced available, and we are, of course, committed to continuous improvement. Together, this makes Technip #1, the world's leading provider of reeled pipe lay services.